Yes, we are now going to move into our application. So let's revisit the theory. So we have equations 1, 2, and 3. These are our axiomatic equations. We use them to derive our kinematic equations, number 4 and 5. Okay, if you guys remember that, that'll be good. What we seek to achieve is to find this initial velocity. So we have everything moving in the x direction, so the initial velocity in the x is just going to equal to the initial velocity. There's nothing happening in the y, okay? So the only things that we're going to need will be the displacement in the x as well as the displacement in the y. So you'll know that you'll see that this ball is actually moving downward and to the right. The equation that we're going to end up using is this one down here. The initial velocity is just going to equal to the displacement in the x direction divided by the time. Okay, and that's because we're firing at an angle of 0 degrees. But the question is, we'll be able to measure our x and our f, but can we calculate time? Yes, we can. We're going to calculate our time utilizing our y kinematic equation, or the kinematic equation that describes motion in the y direction. So we went through this in the theory, and here's the time. We're just going to bottom line it, and time is going to equal to the square root of a -2 times the displacement in the y direction divided by g, which is the gravitational acceleration. It's the maximum gravitational acceleration due to the Earth's pull. So the only two formulas that we're going to need will be these two. After all of that, you say, why didn't you say that in the beginning? Well, it's just the way I like to do stuff. So let's go into video physics. And in video physics, I've already downloaded the video. It's called Experiment here. And I just want to give you a quick picture of this experiment. We saw it a little bit earlier, but I want to remind you. This is our mini launcher where we're firing from. And this is our setup. So the first thing we want to do is label this. So of course, I'm just going to go to the I again. And from the I, we're going to call this initial velocity. So basically, we're calculating the initial velocity. And of course, brass, Eric. Say OK. And let's just go back into that video. The first thing that we want to do is what? We want to calibrate and, well, we want to set the origin and we want to set the scale. So the origin is just going to be right here. And I'm going to go in a little bit. Origin is going to be, here's the origin. So I'm going to place it right below the white, how can I say this, white looking circle. It's really the launch position of the ball. So I choose the bottom because the ball is going to hit the table, okay, on the bottom. So just a little bit closer view, you'll see that we have our origin right here, okay? So now I want to set the scale. So let me just double tap, move back down, and I again want to use 20 to 30. And of course that is 10 centimeters, so 0.1 meters. All right, that looks pretty good. And now of course we want to take a snapshot. I want to be able to see the experiment, your name, the scale, and the origin set. So I'm just going to take a snapshot, and voila, there we go. And so we'll begin establishing points here. And you know what? In the next video, I'll do the points. So that was our experimental setup.